Hi, my name is Luisa. Today I would like to show you how you can use the Regions mode of the DeePathology Studio to identify the hippocampus in mouse brain sections. I've already prepared a little project. So here you can see this is my slide. It contains 4 mouse brain sections that have just been stained with hematoxylin and eosin. My categories are as follows. Of course, the background, which is going to be everything where there is no tissue. As I'm going to focus on the hippocampus, you can see that it has 2 very different types of area. So one is the low density areas, and then you have the high density areas here, where all the cell nuclei are concentrated. And lastly, I have also a category called Other, where I will include all the tissue that is not in the hippocampus, but should still be detected as tissue. So I will start annotating now, maybe with the low density category, and I will just circle a few areas that I would classify as low density, and I would like to give as examples to the algorithm to train on. Also, of course, I need to give examples for the high density regions, which will appear in red here. And I'm just trying to pick from different areas of the hippocampus as the cell structure and staining intensity slightly varies, and I want all of this to be recognized by my algorithm in the end. Now I have 2 categories left. One is Other, which will be the largest portion of the brain. So again, I'm trying to pick out different areas with different staining intensity, different types of cells. And lastly, the background, which is everything that is around here and will appear to be nothing in particular. So you see that now that I've given enough annotations for every category, the studio has already started training. This is indicated in the top right corner here by saying training in action and these 3 moving dots. So you know that now in the background, the algorithm has already started being developed. I can monitor the progress here under graphs. And what I would like to do now is just let it train for a few minutes without me giving any further annotations or interact with it. And then after that, we'll see what it can do and how we can help it to get even better. So I will just let you to watch the train graph together with me. So now that 5 minutes have passed, I would like to see what the model can do. And for that, I've selected, or the studio has selected for me automatically, the best epoch from all the epochs that have passed in these 5 minutes. I will find a nice field of view and run the algorithm by pressing the button Run. And this will apply the best version of the algorithm to the entire field of view. So let's see what it can detect. It's looking already pretty good. And what you can do now is you can improve by giving more training data. For example, I can simply right-click on this area, which is obviously wrong, and right-clicking it will add it to the training data set. And then I also press the number 4 on my keyboard because I want it to be in the correct category. I can do this also here, where I see that small areas or maybe even larger areas, like for example here, have been categorized wrong. What I need to do in areas, for example here, where I can't simply just add it, here I will make a manual annotation and I will just draw the area that has been classified wrongly with the correct annotation. For example, this is also needed here in this area, which has been classified as other, whereas in my opinion, this is low density. And similarly, I can correct the outline here by making an annotation for the category others by drawing manually. So this will give the algorithm more input, and it will try to implement the new information to make a better, more exact and more precise algorithm. I can also go to another slide. For example, here I have one that is much darker and also is cut slightly more to the back of the brain, so the hippocampus is a bit larger. And I can apply the algorithm also to this section and see what is happening. Also, you see that I have some artifacts here, which could be from staining or from scanning. So I want to see how the algorithm deals with this. And there's no problem, so this works really well. I can also add the red area, so the high density areas, with a right click when I'm happy, just to give it more data to work with. So this is the annotations that we've added from here. And I'll make a few manual annotations to better classify the edges of the tissue. But in general, you see that after only a few minutes, we have an algorithm that can quite confidently identify the hippocampus in a mouse brain section.